Hello friends, welcome to Event Academy. In the last lecture, we have started the discussion on the simple harmonic motion. So in this particular lecture, we will start discussing problems on the simple harmonic motion. Okay, so what we have seen in the previous set of lecture is that a simple harmonic motion is a motion in which the acceleration at a particular point is always directed towards the center of force, and this acceleration is proportional to the distance of that point from the center of force. So let us consider a SHM like this. So let us consider a point P here. This point P is at a distance of x from center of force. So let us consider O as the center of force and point A and A dash as the extremities. So this point O is center of force. Center of force. Okay. So acceleration at point P, let us name this as AP. The acceleration at point P is always directed toward the center of force. Okay. So this is always directed toward the center of force. This is center of force. So AP is and AP varies as the distance of this point P from the center of force. So on removing this constant of proportionality, we have d2x upon dt square is equal to minus mu x. Okay, and mu is the intensity of force. Intensity of force. Also, we have seen the expression between velocity and the displacement. So v square is equal to mu a square minus x square. And we have seen that v is equal to v max at x is equal to 0, and we have acceleration is equal to max at x is equal to plus minus a. Okay, and maximum value, how we can find? Let us put a x is equal to 0 in this. So we have the magnitude of maximum velocity is equal to a root under mu, and we have the magnitude of acceleration maximum is equal to mu a. So this we have seen. So the variation of velocity with the displacement is like this. So we have the variation of, okay, so we have here v is equal to v max, and here v is equal to 0, v is equal to 0. And here at the center of force we have acceleration is equal to 0, and acceleration is maximum at the extremities. Acceleration is equal to maximum. Okay, so this we have seen in the previous set of lectures. So let us start discussing the questions. What is this? What is given in the question is that the maximum velocity of a body moving with SHM is 2 feet per second. So V max is given as 2 feet per second, and time period is given as 1 upon 5 seconds. Okay, so what we have also seen in the previous set of lecture, time period is equal to 2 pi upon root under mu. Okay, just we are recalling this. So, so we have the expression between the velocity and the displacement as v square is equal to mu a square minus x square. So we have v is equal to maximum at x is equal to 0. So let us put x is equal to 0 in equation 1. So we have v max whole square is equal to mu a square minus 0. So this is equal to mu a square. So v max का mod क्या हो जाएगा? Is equal to a root under mu. This is given as 2 feet per second. So root under mu is equal to 2 upon a. This is equation 2. And we have time period as 2 pi upon root under mu. So this is given as 1 upon 5 second as per question. As per question. Okay, so we have, let us put value of mu here. So 2 pi upon 2 upon a is equal to 1 upon 5. So a pi is equal to 1 upon 5. From here we have amplitude is equal to 1 upon 5. This is the amplitude. Let us discuss question number 2. At what distance from the center the velocity in SHM is half of the maximum value? Okay, so we have the half of its maximum. So we have v max at x is equal to 0. So we have the expression as v square is equal to mu a square minus x square. So at x is equal to 0, we have v is equal to v max. So v max square is equal to mu a square. Okay. So from here we have v max the mod is equal to a root under mu. Okay. So this is equation 1. This is equation 2. So let at x is equal to x1, v is equal to v max upon 2. Let us take this like this. Okay. So we have v is equal to 0 here, v is equal to 0 here. And at x is equal to 0, we have v max. So let us consider at a distance x1, we have this value as v max upon 2. V max upon 2. And this is v max. Okay. So let us put x is equal to x1 in this particular expression. So we have v max square is equal to mu a square minus x1 square. So this is v max is equal to, sorry, at x is equal to x1, we have v max upon 2 now. So this is v max upon 2 का whole square. So this is v max square upon 4 is equal to mu a square minus x1 square. So we have v max is equal to a root under mu. So this is equal to a square mu upon 4 is equal to mu a square minus x1 square. So this gets cancelled. So we have x1 square is equal to a square minus a square upon 4. So we have x1 square is equal to 3a square upon 4. So from here we have x1 is equal to root 3a upon plus minus. So the distance x1 is equal to plus root. So this is root 3a upon 2. Okay, and this is minus root 3a minus root 3a upon 2. So at these 2 points we have the velocity as v max upon 2. So we have at this particular point v max upon 2. This is at this particular point we have v max upon 2. So let us recall this. So root 3a upon 2. This is our center of force, and this is at these are the extremities. So here v is equal to 0, v is equal to maximum, v is equal to 0, and we have x1. At x1 we have v max is equal to v max upon v max upon 2. Velocity is equal to v max upon 2, and at x is equal to x1. In the negative side we have v max upon 2, and this x1 is root 3a upon 2. As simple as that. So at x is equal to plus minus root 3a upon 2, we have v is equal to v max upon 2. As simple as that. So what is being asked in the question is, at what distance from the center the velocity in SHM will be half of its maximum value. Okay, this we have seen. So we have x is equal to plus minus root 3a upon. Okay, so let us discuss question number 3. So what is given in question number 3? Particle moves in a straight line and its velocity at a distance x from the origin. This is origin. Let us consider a point P at a distance x. The velocity at this particular point dx upon dt is equal to k root under a square minus x square. So we have velocity dx upon dt is equal to k root under a square minus x square. Let us square this. So dx upon dt whole square is equal to k square a square minus x square. So let us differentiate equation 1. So 2 dx upon dt into d2x upon dt square is equal to k square into minus 2x. So this gets cancelled into dx upon dt. So dx upon dt, this gets cancelled, 2 gets cancelled. So we have d2x upon dt square equal to minus k square into x. So on comparing this with the standard equation of SHM, that is d2x upon dt square is equal to minus mu x. So we have mu is equal to k square. Okay. Hence the motion is simple harmonic motion, because this expression is similar to the standard equation of SHM. Okay, so now we have to find the amplitude and the periodic time. So we have mu is equal to k square. So we have mu is equal to k square. So we have to find the amplitude. So we have the velocity as dx upon dt is equal to k root under a square minus x square. So we have dx upon dt whole square, that is v square is equal to k square a square minus x square. So we have to find the amplitude. So what is the amplitude? So in an SHM we have the amplitude is the distance from the center of force where the velocity is equal to 0. So these two are the extremities. At the extremities we have velocity is equal to 0. Let us put velocity is equal to 0 in this particular expression. So we have 0 is equal to k square a square minus x square. So from here we equal to x is equal to plus minus a. This means x is equal to plus a and x is equal to minus a is our amplitude. So x is equal to plus a x is equal to minus a. So these both are the amplitudes. This is amplitude and this is amplitude. These are amplitude. Okay, so let us find the periodic time. So we have the periodic time as, let us find the periodic time. Periodic time. So we have the periodic time as t is equal to 2 pi upon root under mu. So we have mu is equal to k square. So we have root under mu is equal to k. Let us put root under mu as k here. So we have time period is equal to 2 pi upon k. So this is our periodic time. So this is a t is equal to 2 pi upon k is the periodic time and amplitude is x is equal to plus minus a. So now let us discuss question number 4. Okay. So we have the displacement of a particle in a straight line is expressed by the expression x is equal to a cos nt plus b sin nt. Okay. It describes a simple. What we have to show is that this expression, it describes a simple argument. Describes displacement of a particle is given by this particular expression. So we have to show that the particle describes a simple harmonic motion. Okay. And we have to show that amplitude is equal to root under a square plus b square and time period is 2 pi upon n. This we have to show. So let us differentiate this with respect to t. So this is equation 1. So differentiating equation 1 with respect to t. So we have dx upon dt is equal to minus an sin nt plus bn cos nt. Okay. Let us differentiate once again. So d2x upon dt square is equal to minus an square cos nt minus bn square sin nt. This is equal to minus n square. Let us take n square as common. So this is minus n square a cos nt plus b sin nt. Okay, and this is equal to x. So let us replace this with x. Minus n square into x. This is d2x upon dt. On comparing this with the standard equation of SHM, that is d2x upon dt square equal to minus mu x, we have mu is equal to n square. And since this expression is similar to the standard equation of SHM, the particle follows the simple harmonic motion. Okay, so it follows SHM. Okay, now we have to find the amplitude. So amplitude is the distance from the center of force. Amplitude is a point where the velocity is zero. Okay. So we have at amplitude, this is at A we have the amplitude, and at amplitude we have velocity is equal to 0. Here velocity is equal to 0 and here velocity is equal to 0. So amplitude is the distance of particle from center of force where velocity is equal to 0. So we have this as, let us put v is equal to 0 in this particular expression. So we have 0 is equal to minus an sin nt plus bn cos nt. So we have bn cos nt is equal to an sin nt. So we have tan nt is equal to b upon a. Okay. So from here we have sin nt is equal to b upon b square plus a square under root, and cos nt is equal to a upon b square plus a square under root. Okay. So we have sin nt and cos nt like this. Okay. So we have to find the amplitude. Okay. So let us put sin nt and cos nt in equation 1 for getting the amplitude. And we have mu is equal to n square. We have found mu is equal to n square. So putting Sin nt is equal to b upon a square plus b square under root, and cos nt is equal to a upon b square plus a square under root. Sorry, a square plus b square. Both are same. Plus b square. So we have x at v is equal to 0 is equal to a की वैल्यू क्या है, a into cos nt, a upon a square plus b square under root plus b into b upon a square plus b square under root. This is equal to a square plus b square upon a square plus b square. This is equal to root under a square plus b square. So we have amplitude as root under a square plus b square. Also we have time period. Time period is equal to 2 pi upon root under mu. So this is equal to 2 pi upon root under mu is n. So this is equal to 2 pi upon n. So we have amplitude as a square plus b square and time period as 2 pi upon n. Okay. So let us discuss question number 5. What is given in the question? The speed v of a particle moving along the axis of x is given by v square is equal to n square 8bx minus x square minus 12b square. Show that the motion is simple harmonic motion with center as x is equal to b and amplitude is 2b. So we have the center as x is equal to 4b. This we have to show. So let us differentiate equation 1 with respect to x. So we have 2b into dv upon dx is equal to n square into 8b minus 2x. So this we are having is that 2v dv upon dx. V dv upon dx is acceleration. So we have 2 into v dv upon dx is equal to minus, let us take minus common, so minus 2n square x minus 4b. Okay, so we have the acceleration. This is acceleration. So v dv upon dx is acceleration. So we can write dv upon dt as dv upon dx into dx upon dt, and dx upon dt is v. So this is v dv upon dx. This is acceleration. Okay, so we have the acceleration as we can write as d2x upon dt square equal to minus n square x minus 4b. Okay, so this we can write as d2 into capital X dt square is equal to minus n square into capital X. Okay, so on comparing this, we have capital X is equal to x minus 4b. This means we have center of force as x is equal to 4b. So this is our center of force. So let us find the amplitude. So amplitude is the position of a point such that the velocity is 0 there. Okay. So we have to find a point where the velocity is 0. Let us find the points of 0 velocity. So let us put v is equal to 0. 0 is equal to n square 8bx minus x square minus 12b square. So we have x square minus 8bx plus 12b square is equal to 0. So we have x square minus 2bx minus 6bx plus 12b square is equal to 0. X minus 2b minus 6b x minus 2b. This is equal to 0. So we have x minus 2b or x minus 6b is equal to 0. So we have x is equal to 2b and x is equal to 6b. So at x is equal to 2b, velocity is equal to 0. And we have x is equal to 6b, velocity is equal to 0. So this means these points x is equal to 2b and x is equal to 6b are the points of 0 velocity. So at these 2 points we have velocity is equal to 0. Velocity is equal to 0 and velocity is maximum here. So at points of 0 velocity we have amplitude. So this distance is amplitude. This distance is also amplitude. This is center of force. Center of So what is this distance? So this whole distance is 4b minus 2b is 2b, and this distance is 2b. So we have amplitude as amplitude is equal to 2b. Okay. So that the motion is simple harmonic with center at x equal to 4b and amplitude as 2. Okay. So we have discussed up to question number 5. We will discuss further questions in next particular lecture. Thank you.